this is how to solve this question. So this question has given us a curve, which is y equals to f of x. And looks like a cubic curve. Now the question says the equation of the tangent to the curve at point T, which is minus 1, 6, is y equals to x plus 7. At a point R, another tangent parallel to tangent at T is drawn. The gradient function, which is the derivative, is given by dy of dx equals to 3x squared minus 6x minus 8. Find the coordinates of R. So we've got a couple of key pieces of information here. So first of all, the fact that both tangents are parallel means that their gradients are equal. And since tangent 1 has an equation that is in y equals to mx plus b form, therefore the number in front of the x, which is 1, would be the gradient of the tangent. Since the lines are parallel, since the tangents are parallel, therefore tangent 2 also has a gradient of 1. In order to find the coordinates of point R, we can go ahead and solve the derivative equation by letting it equal to 1, which will bring up the coordinates, the x coordinates at which those points would ensure a gradient of 1. Now, that's just going to give you the x coordinates. How do we find the y coordinates? In order to find the y coordinates, we actually need to find the original curve, and that's what we're going to do first. In order to find the original curve, we need to take the f dash of x equation and integrate it. So let's go ahead and do that first. So y dash or f dash of x, doesn't matter, you can write either, equals to 3x squared minus 6x minus 8. And so therefore y, which equals to f of x, equals to 3x cubed. Remember, add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And don't forget to add c, since this is an indefinite integral, and we need points to actually find out what that c actually is. So therefore, f of x equals to x cubed minus 3x squared minus 8x plus c. I will box that because I will need to come back to it. So now what we also know is that at f of minus 1, f of x is 6. So therefore, we're going to go ahead and plug that in. And that all of that needs to equal to 6. So that would be minus 1. And since c equals to 2, I'm going to come back and modify this equation. Great. So now we can get rid of all of that and move on to the next part of our question. So now that we found that, what we can do is come back to this derivative curve and let it equal to 1 in order to solve. So 3x squared minus 6x minus 8, which is the derivative curve, equals to 1 at the points of those tangents. So let's go ahead and solve that. So that will be 3x squared minus 6x minus 9 equals to 0. Divide everything by 3 and you'll get x squared minus 2x minus 3 equals to 0. Let's factorize that. And so we get that there will be two tangents that give a gradient of 1. One at minus 1, which is the known one, and the other one is at x equals to 3. And so the coordinates of R have to be 3, comma something. Now, at x equals to 3, y equals 3 cubed minus 3, whoops, 3 squared minus 8, 3 plus 2, which these cancel, leaving minus 24 plus 2, which is minus 22. And so therefore, the coordinates of R are 3, minus 22, and that is your answer.